One of Einstein's most famous theories is the theory of relativity, which actually consists of two parts: special relativity and general relativity. I'll focus on special relativity here since it's easier to explain and had a revolutionary impact on how we understand space and time. Special relativity 1905. At its core, special relativity is based on two simple principles. 1. The laws of physics are the same for everyone, no matter how fast you are moving as long as it's not accelerating. The basic laws of physics like gravity or motion work the same. 2. The speed of light is constant, no matter how fast you're moving or where you're measuring it from. The speed of light in a vacuum is always the same, about 300,000 kilometers per second, 186,000 miles per second. These two ideas might seem simple, but they lead to some mind-bending conclusions about how space and time behave, especially when things are moving very fast near the speed of light. Key concepts in special relativity. Number 1. Time dilation. What it means: time moves slower for objects moving at very high speeds compared to objects that are stationary or moving slowly. Example: imagine two twins. One stays on Earth and the other travels in a spaceship near the speed of light. When the traveling twin returns, they'll be younger than the one who stayed on Earth. This effect is called the twin paradox and has been confirmed with experiments involving high-speed particles and precise clocks. Number 2. Length contraction. What it means: objects moving close to the speed of light will appear shorter in the direction of motion from the viewpoint of a stationary observer. Example: if you saw a spaceship flying by at near light speed, it would look compressed in the direction it's moving, even though people on the spaceship wouldn't notice anything different. Number 3. Mass and energy are equivalent. What it means: mass and energy are two forms of the same thing. This is famously expressed by Einstein's equation E equals mc, where E is energy, m is mass, c squared is the speed of light squared. Example: this equation means that a small amount of mass can be converted into a huge amount of energy, which is the principle behind nuclear power and atomic bombs. Why special relativity matters. Before Einstein, space and time were thought of as completely separate and absolute. Special relativity showed that they are linked, forming what we now call space-time, and that they change depending on how fast you're moving. The faster you go, the more time stretches and distances shrink. These effects aren't noticeable in everyday life because we don't move anywhere near the speed of light, but they become significant at extremely high speeds and have practical implications in modern technology. For example, GPS satellites have to account for time dilation effects to provide accurate positioning because they're moving fast.